Okay, looking at question 3 of Carbonyl tutorials, we are looking at a Jasmine compound. Okay, so we are supposed to look at how compound A can be synthesized to form Jasmine in a two-step process. Alright, so looking at compound A, we have a secondary halogenal alkane, and in Jasmine we have a ketone. So in the two-step synthesis, it's quite straightforward. If you think backwards, a ketone will come from a secondary alcohol. And a secondary halogenal alkane can easily give a secondary alcohol via nucleophilic substitution. Okay, so from this, let's take a look. First step, we'll be using NaOH equals heat, nucleophilic sub, you get your secondary alcohol. Okay, secondary halogenal alkane, you get secondary alcohol. Okay, and to get your ketone, simply oxidize, right? Okay, so simply do oxidation, but in this case, take note that we cannot use KMnO4. We can only use potassium dichromate, acidified with H2SO4 and heat to oxidize the secondary alcohol to a ketone. Why is that so? Because there are other functional groups that can be oxidized by KMnO4. The alkane's functional group, okay, can be oxidized to form can be oxidized by KMnO4. Alright, results in the CC double bond breaking. Okay, so do take note. Alright, in this case we can only use potassium dichromate. Okay, moving on. In B, we have Jasmine and a Jasmine derivative compound C. Alright, so this is just a chemical test to distinguish the compound and state the expected observation. So for such a question, chemical test question, we always look at the functional group. We have a ketone, so can't distinguish them based on ketone. Alkene, alkene, and alkene. Alright, the only functional group that in compound C you have that Jasmine doesn't have is the aliphatic aldehyde group. So to test for aliphatic aldehyde, we can make use of Filling's reagent. Alright, and heat. Okay, so compound C, because of the aliphatic aldehyde, will form a brick red PPT of copper 1 oxide. Okay, copper 1 oxide. And Jasmine will have no brick red PPT. So take note of how we write observation. For observation, we write a positive statement. For the one with a negative test result, we cannot write no observation. We have to write the negative observation, no brick red PPT in this case, for Filling's reagent. Alternatively, I can also use, this is also an aldehyde, can also use a Tollens reagent. So I can use Tollens reagent, of course, and heat. Okay, compound C will form a silver mirror or black PPT of silver. Jasmine will have no silver mirror or black PPT. Okay, so these are two tests based on the functional group, the aldehyde, or more specifically the aliphatic aldehyde. Okay, we can also make use that the aldehyde can be oxidized to do a distinguishing test, and aldehyde can be oxidized to form a carboxylic acid. So in this case, we can also consider using potassium dichromate to oxidize the aliphatic aldehyde. Okay, whereas Jasmine cannot be oxidized by potassium dichromate. Okay, so we can use acidified potassium dichromate as I mentioned. And heat, where aldehyde can be oxidized. So compound C, the orange acidified potassium dichromate will turn green. The aldehyde functional group is oxidized, whereas the dichromate from Cr2O7 minus in the +6 oxidation state becomes Cr3 plus 3. Alright, so dichromate is reduced to +3, whereas Jasmine will remain orange for the potassium dichromate because there's no oxidation. Okay, take note, in this case, you cannot use KMnO4 again for a similar reason, because KMnO4 is a very strong oxidizing agent. Right, it will oxidize the alkene and cause oxidative cleavage of the CC double bond. So in this case, both Jasmine and compound C will be oxidized by KMnO4, and therefore KMnO4 is not a suitable chemical test. Okay, with that, I'm done with question 3.